Hey, hello everyone. My name is Vicente Mediano. I'm an architect from Chile. I'll present you now my defense on my thesis on automated code compliance checks with BIM. The main motivations that led me into this work are mainly my previous experiences as an architect, especially my interest on improving, optimizing processes, especially in addressing compliance checks that present a lot of challenges. It's a very tedious process, and it lacked the incorporation of BIM in this aspect. I developed this work in collaboration with BIM Architecti, which is an architectural office here in Slovenia. And they provided me with a lot of guidance towards the Slovenian code and their workflows. So the methodology was divided into three main phases: investigation, frameworking, and application phase. Divided into three phases, each one with own small steps. It was not a linear process, as you can see here in this.
We can only see the main window of the PowerPoint. I don't know if you put on presentation in another screen.
Maybe this one.
Oh yes, that's it. Sorry.
Okay. Okay, this is the first slide. BIM and now the frameworking, the methodology. Well, these were the main steps within the work. As you can see, it was not a linear process. A lot of different phases were related among each other. But the main structure of the work was the development of the framework for facing automated compliance checks. The first phase, the investigation one, was dedicated to analyzing the problem, which mainly has to do with how the manual compliance checks nowadays. It's a very tedious work, as I previously mentioned. It involves a lot of different actors, and it's not aligned with the BIM process. And there's a lot of disconnection between different stages. Therefore, this is a very repetitive, time-consuming, and error-prone process, which makes it also a very expensive one. Additionally, the main issue behind it is the difficulty in how to take the written concepts and translate them and relate them into spatial elements through semantics. This is usually done manually and with the help of external consultants or specialists. In contraposition, the automated compliance check is a more streamlined process, in which is aligned with the BIM principles, and it's more efficient and fluid. As you can see in this image, it only involves a few stakeholders. Nevertheless, this also has some challenges, which is mainly how to translate the written text into machine readable or code format. And for this work, this was done through expertise of my own past and the application on the use of technologies and guidelines. Then the frameworking phase, as I said previously, is the definition of the framework that I developed for tackling this problem. It mainly consisted in these seven different steps based on the digital review that I did. And the first one is the model preparation phase, which has to do with taking the BIM model and standardizing it through the use of authoring tool plugins. It could be done by many, but I chose Revit Model Checker, and the visual programming as the main tool for developing the process to address the challenges, the faults identified by the authoring tool. The next one was the rule classification. It's the first step into a very basic analysis of the written rule that mainly gave us two outputs. The first one is an encoded rule and also a classification table for a very primitive analysis of a rule. This is the format I developed for the name convention on the rules. It basically consisted in taking many characteristics of them and arranging them and formatting them to have a consistent way of working with them. And the classification table, which consisted in grouping characteristics, different type of characteristics of the rule to have use as a guideline for the previous translation of the rule. Yeah, this is the format that I developed, and I will show you at the end how it works. Then the rule interpretation, that mainly its purpose was to generate a pseudocode rule using AI language models as GPT or Find, Google Bard, and Notion. It doesn't matter, but the main thing is using the RASE methodology to structure this pseudocode, and also use it as a guideline in the rule translation process. Then the translation of the rule that consists in taking these outputs, the pseudocode, the specification table with its coded format, and through programming, the visual programming languages translated into a VPL format, visual program language format. I also developed some recommendations and step-by-step on how to optimize this process and make it easier and more efficient. And the rule execution that basically consisted in simplifying the application of the rule for people that are not, or users that are not good with programming. In my case, what I did was configuring the Dynamo player in Revit, so it can be easier for people to execute the rules. And the outputs were the rule checking results, which is generally a Boolean or whatever format can be done, and the reviewed BIM model. And finally, the report checking results that is taking this the results within the reviewed model, and inside the same visual programming tool, generate a compliance report that may be internal or external according to the need, and within any of these four identified formats: written, tabular, visual or graphic, and cloud-based. I also developed this I.0 graph to have a general idea on how it works, the whole workflow, and the decomposition of this, so just to identify and to show that the process was not linear either. It had a lot of feedback and back and forth, and a lot of iterations just to make the process as efficient as possible. And a graphic representation of the whole process that mainly consisted in taking the written rule and the BIM model as an input and obtaining a compliance report. And finally, the application phase, which consisted in taking the Slovenian regulation, because the context of my work, I was working in collaboration with this architectural office as a BIM specialist, and I selected in collaboration with them 3 rules and applied it to a project located here in Slovenia, in Novo Mesto region. And these are the classification tables for each of the 3 rules. As you can see, there are a lot of recommendations, and you can just not depend on the rule anymore and take this classification table as a guideline. And the same with the pseudocoded rules. I decided to use 3 different artificial intelligence tools just to make an example on showing that it's irrelevant which one do you choose. A few of them were pretty useful. And finally, the Dynamo graphs I developed for checking the project. Each of them had different stages and different complexities. This was a medium complex one. This one a very complex, and the last one was very simple, depending on the type of rule. And at the end, each of the 3 reports generated. The first one was an external report in Excel, tabular with a compliance column. The next one was an internal report, a visual one that generated revision clouds for the non-compliant elements. And the third one was also an internal and visual one, but in this case, I highlighted elements that were not complying with the rule. The main findings of this work, of course, is the practicality and adaptability of the framework, and the fact that regarding of having a really high upfront investment in time and, of course, resources, the long-term efficiency is outstanding. The use of BPL provides flexibility and transparency, which is one of my main challenges, as Solibri or other rule checking tools are not transparent and are considered black box solutions. The reduction of risks that automated compliance checks present towards, in comparison with manual compliance checks, was also a very beneficial outcome. and the streamlining of tasks, no redundancy and errors because of this use of a systematic analytic workflow. And finally, some limitations of the study with the scalability of different rules. For instance, as I showed you, the third rule was a bit of an overkill of this framework because it was a very simple one to develop. It took me like less than one morning, and the more complex one could be not enough. Also, the debugging for different projects, as not every project has the same type of parameters and the same type of characteristics, so it's a big issue to face. And the quantitative approach for measuring efficiency, because I didn't have the tools or time to measure quantitatively or like more specifically how much time does it save, but according to what for the feedback of the team, of the architectural team, they said it was really good. And finally, the use of open standards in the industry provide a more universality, but it might need to generate additional steps. Generally, offices work with authoring tools or with proprietary software, so I chose to take this path. But this is a very important thing to consider. And as a final thought, I really wish that the digital world and technologies evolve. Professionals would need to adapt to these new processes, and specifically in programming and technology, as they become even more present in our day-to-day life. And finally, I really hope that this process as a methodology is useful for people, not necessarily for automating compliance checks or even BIM, but as a way to approach problems in a very holistic way. In this case, was for automated in BIM. Thank you very much.